Do what now? Oh, sorry.
I hide my pain. No. I don't, I'm just a happy person. So yeah. That's really sweet. I'm like, I thought you should do that. It's crazy.
That's what I
Hello? Oh yeah, I saw that. Yeah. It won't be taught in college for a while, but yeah, I like it. Yeah, I like it. Uh-huh. Well, yeah, they're going to be called smart pointers. They are called smart pointers. Yep. Mm-hmm. Kind of like Swift did that with their new language update. Kotlin's done that with the Android update. So yeah, it's a good move. Okay, well, hopefully those are connected that are connected online. If you are connected online, you need to, when you click on the YouTube link, you need to log in to Google and sign in with the chat like it's on the screen here. So I can know that you are here. Looks like there's 12 watching. So go ahead and do that. Give you a moment to do that. Again, click on the YouTube link or the podcast link in week 11 podcast. Don't expand the screen for the YouTube page. On the right side, there's a chat module. You'll need to log into with your Google RBC Google email and put in your full name in the chat feature on the right side. If you do go full screen, you won't see the chat feature on the right side. We'll give another moment to do that, and then we'll begin our Kahoot. And you guys checked in with the app, right? Up here? Cool. All right, I got 13 connected. I'm going to go and get started. If you've not connected to Kahoot, don't worry about it. This will be a recorded post session. So this is over chapter 16 on file input output. Let's begin. 8 questions. OS Stream allows to read or write files. Read, write. Which one? OS Stream. Read or write files. What's the purpose of the OS Stream? That's all right. All right. If Stream allows you to read or write files. Again, initializing a file, a name, if Stream. Hopefully most of you get this one right. There we go. And just O out, I input. O output, I input, if you remember that. Storing data in files allows data to be more permanent. True or false? So up to this point, I've stored in variable only or arrays only. True, very true. If stream data file with test.txt in parentheses, this is blank file data, writing or reading file data with this initialization line. Remember the tip I gave you earlier. There we go. And most of you got it. It is reading. Remember IF, just remember I for input, OF, output. All right. OF output or out file, and then out.dat blank a file named out.dat. Deletes, creates, or reads a file named out.dat. What is that initialization going to do? It will create iOS : app, appends data to a file, goes to the end of the file when opened, or open for input. And this is for initializing a file. It is append. An easy way to remember this, and you'll see more of these when we go over notes, is the APP stands for append. In, iOS : in, open for input, output, inclusion. Your first guess is going to be right. All right, there we go. Should you create file and open before using a file in C++ for input and output? Yes or no? Should you create the file, the text file, whatever it is you're going to be calling that file? Should it be created before using it and open it up? Yes, you should. Yep. All right, there's results. A couple announcements. I had to redo everything in the Seesaw app, which in the announcement, and I apologize for that mess up, but in the announcement last week, and I've used it before in other class, but they changed the way they do it. I had a QR code to sign everybody up, but now you guys are going to use a code. So if you've already done one, which I know most of you did, I didn't delete any of the existing journals, which has my name on all of them. So when you sign up the correct way now, find your journal post and just paste it into a new journal post, basically, is all you got to do. I've already graded if you submit it up till Sunday that you did it. So I didn't delete anything. So make sure and do it. I'll give you an example. I'll pick on Laura. Here's Laura Angels. And she's here tonight, right? Yeah, here she put a found pictures for all characters and began researching background and character navigation. And then came up with necessary trivia questions plus ability of each character and synopsis for the beginning of the game. So just a couple journal posts on what you're working on, or even a cool app idea that you have. You can put that in there just to get you used to journaling, which I do a lot of on a daily basis. Otherwise, I forget. I wish I didn't. I wish I had photographic memory, but I don't. And so journaling will help you to do that. And so again, if you post it, if you can see, I'll scroll through the ones we've done thus far, the ones that submitted thus far. As you can see, there's a couple for Tim. Okay, I did not post this one. I did not post that one. So anything that has a CK on it, I did not post, but you know who your post is because you posted it. Again, you can just find yours, copy it, hit the plus symbol, go down to post a student journal, and then it'll post it to your account. So there's a few that have already signed in, like Samantha, Tim, Carrie, Joe, Caleb. You just have to paste yours that you've already done in there. And then once those are all done, I'll give it a few, through Sunday to do all that. I'll delete all the ones that have my name on it, basically, that I did not post. Make sense? All right. Oh, and by the way, if you do have questions, as always, as we're going on, if those of you are online, there is a way to post in the chat module a question here. But again, you have to be logged in as a user account before you can post. And so on the right side, you can type in your question. Once the session has went dormant, and we've ended the the live YouTube session, you won't be able to chat anymore. But up till that point, you can ask questions in there. So if I don't get to them in the live session, I'll get to them in post session. So that's the seesaw I wanted to talk about. Let's see. Also, final topic in the course conference, final app help. When you click on that, it'll go to the final app resources on app requirements, some suggested personal dates to meet for yourself just to make sure you're on task. Code helps, you'll link to that. If you're doing a game, link to that. I updated this go.engine.org for those of you using that, which a couple of you are doing that. And if you need any help on anything or any code examples, definitely let me know. But I try to put in that final help as many resources as far as code help resources that I think will help you as far as online text we've used or resources outside of the class we've used. So definitely avail yourself to that. All right, so this week we're going to look at reading and writing to a file and using I/O. Next week we're doing the debugging. And week 13 and 14 is strictly working on your final app. For those of you that are online tonight and didn't come in and you're working on your final app from home, you can do the same again next week if you want to. It's up to you. But I will be here either way from now to the end of the semester each week. Next week, I will be bringing some hard copy text into the classroom. They're kind of older, but they're good. I think good references. So even if you maybe are online next week, I'll leave them in the classroom and you can come in and grab them. And when they're gone, I'll just use your honor system to give them back to me at the end of the semester when you're finished with them. I'll probably bring 8 or 10 of them in to help. And they're not any better or worse than the online resources. They're just other resources to help. And some students like a book. Personally, I used to be that way. Now I'm more online on everything or an app or something like that I download. So if you still like a book, I'll bring some in next week to help you.
You tried ordering books off Amazon or using Amazon Gift Card, but they're real nice. They never order in seconds. And they have your credit card, and you get the book right there.
Oh yeah. It's and what's a lot of colleges are doing now is for their books, their textbooks, we're allow them to rent their textbook, and then I don't know if anybody does that in here, but you rent your textbook, right, like a PDF thing, and at the end of that semester, it deletes it from your device at the end of the semester. So like $100 psych book might be $25 to rent it for a semester, which most students return that book at the end of the semester. So instead of paying $100 and get maybe, I don't know what you get back, 60, $70, whatever it is back, you don't get the full amount. So yeah, that technology's been out for a while. It's kind of cool. So we talked about the app journal, we talked about final app resources, reading. We did the Kahoot on that. Now I'm going to go into some of it's in the slides, which is in the examples for week 11. And so if you go into week 11, there's a couple links. At the top, there's a week 11 PDF I'm going to go over right now. And then we'll go over some examples of some C++ apps on reading and writing files, along with some challenges for you with those. And then we'll go over your take-home app, as always. So I'm going to go to the slide first. Let's see this one right there. So thus far, we've been importing or inputting data with our keyboard and saving it in an array, saving it in a variable, which is good while you're learning how to do coding. But the next step is to update something permanently or data permanently, have some type of source file to save it at. One of the easiest way to learn initially is a read file, like a text file, or we're going to use text for this week, but it could be any extension you want it to be, technically. To read and handle large amounts of data, both input and output. Another type of data backend you probably heard of is like SQL database or SQLite database or MySQL database or Progress database or Access database. These are all popular databases. The most popular today, or creeping up there in popularity, I would say would be your backend online cloud-based databases, like Firebase, which is a Google-based platform. Amazon's another one. So between Amazon and Firebase, those are the two, they call them big data platforms, where folks are, companies are now creating most of their apps with those as a backend database, because they're being connected via different devices like iPads, Androids, phones, whatever, and they can push and pull regardless what the device is. Much easier. So how do we store things permanently? Glad you asked. We can use a secondary storage device, like some of you remember floppy disk. I know Jack does. Anybody else remember floppy disk? Or have a computer maybe at home will still have a floppy disk. Anybody? All right, cool. In my 110 class, we still do a number of the computers and we work on have floppy disk, and I always hand out during one of the labs an actual floppy disk, which as the years have went on, I would say 5 years ago was about 50% of the students had never seen a floppy disk 5 years ago. Now, 80%, 85%, they might have seen a picture of it, they never actually held a floppy disk. And so as we keep going on and on and on, it'll be that way. And so, but we have to have some type of secondary storage, whether it be back in the day floppy disk, now USB, cloud drive, back-end database, somewhere to store data in what's called structured files, a structured file format. And so files in programming, to read and write, regardless what the platform is you're saving them into, is what's called streams. And so you've either read stream or write stream. Same with web browsers. If you're browsing a video on Netflix, it's streaming, and that's where people actually know of that term today, probably more than anything, is when you hear streaming, you think of video. But streaming still serves the same concept in regular static files. So reading files, writing files. Now, granted, that stream is much less overhead and much less cumbersome than a video file or an audio file, but it's still a stream. And basically, where files are used to store data in relatively permanent form. And when it says relative, that's why on that Kahoot I said almost permanent or kind of permanent. Files can get corrupt, database can get corrupt. Nothing's like 100% permanent. Like it's it forever, right? And I guess I'll stop there to maybe help you, because we're getting near finals for everybody in the college, those of you in class and online both. If you're working on papers, which I know you are, research papers, you're working on stuff for other classes, even our class, make sure to make a backup of that stuff, whether it be email it to yourself, your code. I know most of you are putting it on GitHub already, but if you're not, put it on GitHub. That way it's saved. If you don't put it on GitHub yet, at least put it on like Dropbox.com or a Google folder, something like that, a Google Drive, to where you're backing up your data, because you don't want to lose your paper you've been working on or your app you've been working on for weeks on end, right? So make sure and back it up. Floppy disk is another one. It can be saved to hard disk, or today would be the static solid state drive is real popular for computers now, and tablets. Even tape is still, believe it or not, around, with servers backing up tape data to tape. Most consumer levels aren't going to use that at home, but back in the day, right after one of the first forms of backing up was a zip disk. I don't remember those. Zip disk actually was a tape inside the zip disk, right? A pretty good size one. But they held, they started out like 20 megs and 50 megs and 100 megs and 200 megs. It kept incrementing up. So tape's still around. But files can hold huge amounts of data if need be. And so, again, text is going to be much less than like video or audio. as far as the level of order of what takes more space. Audio is going to be number one. So if you watch a movie, the audio portion of a movie is much more greater than the pictures in that movie, the sequential pictures in that movie. So audio, then images, and then text. And that order is the order of sequencing of file size. Ordinary variables like we're working with this week, like text names and things of that nature, don't take up a lot of space. Arrays don't take up a lot of space. But initially the program's going to keep it in main memory, and then it's going to stream it temporarily from that main memory into whatever resource it is you're saving it to. Whether, like this week, we're actually saving it into a physical file name on the web server where Replic's at, is what we're doing this week. So why use files? It's a convenient way to deal with large quantities of data. It stores data permanently or until it's deleted or corrupt, which we've talked about already. Avoiding to have to type data in multiple times in multiple different programs. You can have one database and share it to umpteen programs, from a C++ program to an Android to an iOS to a web-based application, whatever. You'd also share data between multiple programs, like I mentioned, regardless of what the platform might be. So 2 types of storage comparisons here on this slide is main memory and secondary memory. Main memory is memory on the chips on your computer or web server, like we're using in Replit. It'd be a web server where it's hosted at, but your computer at home, if you're writing a program on your laptop or desktop, it's the actual chips in your computer that are holding in memory the functions that as you're typing them, the code as you're typing them. It's used to hold the program when it's running in real time. So like the browser I'm using tonight, Chrome, is being ran in multiple memory slots in my Mac in order for it to run and to stay static and fluid. And it can be either integers, characters, arrays, etc. that's in that program values. Secondary memory, disk drive we talked about, like magnetic tape, solid state drive, we talked about that. Used to hold files where a file contained data, program, text, video, audio, on and on and on. The list could go. And it can hold large amounts of data. We're getting to petaflops and teraflops and, different types of data increments that weren't even talked about just 20 years ago. I mean, there was a comment made by Bill Gates, I believe it was in the late 80s. It was a 32 meg computer at that time, which was actually pretty large in memory, 32 meg memory at that time, which was a really large then. But he was quoted as saying, "This is the most memory any computer will ever need." Okay, and that was in the early 80s, and so it just keeps incrementing larger and larger and larger and larger. So main memory can hold relatively small amounts of data, and again, this is your temporary chip memory that's held in the computer or the web server. It's temporary, meaning as soon as a program dies, like we've run up to this point, as soon as Replit's over and you run the program, whatever it might be, whether it be multiple loops of, say, grades or calculations or whatever it might be, when that program's over and you run it again, the data's gone. Or actually, when the program's over, it's gone. Data's gone. Values are gone. So this is fast for things like calculators is an example of that, right? A calculator, you generally don't save data in a calculator. It's just used for, calculation on the fly, whether it be trig or it be calculus, whatever it might be. Secondary memory, though, can hold rather large amounts of data. And instead of being temporary like main memory, it's fairly permanent, where it's saved in an actual file like we're going to be playing with this week, or a SQL database type file, or a progress type file, or an access database type file. But still, it's an actual file. Because even like SQL, progress, access, the root of these databases I'm talking about can be traced to one file name, okay, that it's being pulled from. And as long as it's not erased, disk isn't damaged or corrupted, it will be fairly permanent. And then access to data can be considerably slower because we're not dealing with temporary memory. We're dealing with taking data and say it's a database that has 1 million records or a file that has 1 million records. A file that has 1 million records is going to take much longer to read, right, than a file that has 10 records, right, or 100 records or 1,000 records. Now, in the database language, which you'll learn in other classes if you haven't already, in the database terminology, you can do what's called indexing to make those file searches and faster, right, by indexing certain fields within a database, like an index field, to give you an example. So I/O in C++, I/O, basically input and outputs in C++, uses streams, and stream is general name given to the flow of data, whether it be input or output, reading or writing, reading or writing. So flow of data here in this diagram, you have on the left side the I stream, the right side the O stream. Remember I, input, O, output, writing, input, reading. And so if we're inputting stream, extracting data in a program, and it's going through the circle there, and it's a clockwise circle where the data basically is maybe inputted from the user on username and password, let's say, and it stores it in the database as an output file or in a file, and then they calculate, put it in their username, put it in their password. It checks the database or checks that file to see if it's correct. Right. Another one might be better for text files. Would be like your Windows computer, right? Your Mac computer, Linux computer keeps a security log of every attempt to log into your computer, both successful attempts and unsuccessful attempts. Right. It gives you a timestamp, date, time, seconds. Was it successful? Was it not successful? Things of that nature. And so input and output, devices and programming really doesn't matter. Even the file really doesn't matter. The process is the same, regardless if it's a large database file or one text file like we're using this week. You're going to have an output stream, insertion operator. You're going to have an input stream, extraction operator that's going to be inputting data, outputting data. And so now we need to know how to connect file to program, how to tell the program to read data, write data, and also end a file. Okay, determine if something's end of file or not. We'll look at some examples of those as well tonight. If something's end of file, meaning you've reached the end of the file, you've read everything up to the last character of that file, and you're done reading. Programming needs to know that too. Or you could have like an overflow. So different streams are used to represent different kinds of data flow. Each stream is associated with a particular class built into C++, a library. Member functions, definitions for dealing with different types of data flow. And so the three types of C++ classes, or three names for the C++ classes for input and output, are IF stream, OF stream, and F stream. And so this screen talks about the different ones and what they're kind of used for, the sub-methods. And so O stream, output, putting or writing, as an example. Then you've got if stream, opening, telling, seeking. Another sub could be for that as well. On the F stream is OF stream, opening, telling, seeking. These are both. And then IS, the I stream, getting line, reading. And you've used that up to this point, like a cin.get line is an example. You're reading an input from a user, except they're reading inputs also from files as well. So F stream, IO stream, O stream. So when you're opening a file, associating a file with a stream of the file, you're going to have to use some constructor. In this case, an example of that constructor stream is IF stream. So we're opening a file, if stream transaction sales.dly. OF stream result.o2. And so we're defining here what type of file, what this file is going to be used for, whether it's going to be reading or whether it's going to be writing, basically. There's more to it than those two, but those are the basics, reading or writing. So by using the open function in the stream class, for instance, if we did this if transaction and then transaction.open sales.dy. By the way, the new version of C++, you don't need to do the .open. You'll see that in the examples tonight. You can just, and in your text, it talked about that. But you can just do like if stream transaction and then just the sales.dly. That's all you got to do. And it'll actually go in there and open that file. Here's the different parameters when you're getting ready to open a file and to write, say, to a file. One of them was in the quiz, was the app for append. But then you have ATE going to the end of the file and opening, binary, IN just for reading, no create opens a file if file doesn't exist, open fails if file doesn't exist, no replace open fails if file already exists, out just creates a new file for writing on, and the out, by the way, will create a new file every time. So if a file already exists, it'll overwrite the existing file in there. Okay. Trunk will delete contents of existing file. The two most popular ones we'll be playing with this week is the app, which is appending the file, and end. Those are the two most popular by programmers, but these other ones can definitely also be used as well. Like the out's used a lot of times on beginning a file program to make sure that file exists. If it doesn't exist in a folder, the out will actually create it for you if it doesn't exist. In the Kahoot, it's a good program. It's good programming to create that file for the program before it's used, whether it be in the root of that program folder or other places. So you can also use, by the way, a combining of two or more by using the OR statement, the OR operator, the bar there. And so when you open a file to see if it's successfully opened it right, you can do this here if transaction equals null. I just use the if and then exclamation point transaction. That's all you got to do. Okay, and then it's going to determine if that transaction indeed is null or not. The not operator, the in front of the transaction. So in this case, if it's null, it's going to be unable to open, and cin.get, waiting for the operator to press the key, and then the next one would be to exit out of that. Anytime, and this is a key one, anytime you either open a file to read or write, either one, make sure you close that method as well. So whatever you named it to open or named it to write, make sure you do a .close, which you'll see some examples of that. If you don't do that and you go back again later, like right after, to do another transaction and the file's open from the last one, it won't let you do anything. It'll just kind of like, if an example would be, if you had a Word document open or Excel document open on a network file, network folder, and I want to open that same file, it would say, Jerry's got the file open. You'll have to wait. Same type of thing. So if you don't do .close, it doesn't close that stream to where it can be used again. That makes sense? So just make sure when you open a file in database connectivity or file database connectivity language programming, you do a .close. And that goes for all programming languages, by the way, not just C++, for all programming languages. So two basic type of files that we're going to play with. We're going to play with the text files tonight, but also it'd be binary as well, or text files, either one. Binary is going to be mainly used if you're using variables like char to do reading and writing. We're going to use string this week, but you could use char as well. And I have some examples that you can have as well if you want to do it that way. Most programming languages use string now, especially it's just more efficient, and it writes faster and reads faster if it's using a string variable versus a char variable. So a text file consists of readable characters set in different lines by a new line character. So at the end of the line, you're going to have a slash n. Okay, a slash n is a new line that it tells that compiler this is a new line in the file. And on most PCs, the new line character is actually represented by the 2-character sequence and the ASCII code called 13, 13. And it's a line feed also of ASCII code 10. Return is 13, line feed is 10. And it's going to be that -n, basically, or /n. So binary, a file, will store data to disk in the same form, which is represented. If you've ever tried to edit a binary file containing numbers, you'll see that the number appeared as nonsensical. Okay, it kind of looks like a bunch of gibberish with a whole bunch of symbol gibberish. We're not doing that in our example this week, but binary files would do that. Binary files, not having to translate numbers into readable form, makes binary files somewhat more efficient. Binary files also do not normally use anything to separate the data into lines, such as a file just use a stream of data and nothing particular to separate it. So text files, when using a text file, we write out each separately piece of data or each record, and that's why it's used a lot in database language today, because everything in database language today, and has been forever, is by record. So customer record, user record, whatever the case may be. And then the text file can be readable by an editor. Like I talked about earlier, the Google and the Amazon backend database platforms, Firebase and Amazon both do what's called JSON for all their database language now, which is a very readable. If you've ever seen a JSON database string, it's very readable. It's all kind of jumbled together, but all the words are readable and separated by usually a common delimiter, like a comma or semicolon or something at the end of each record. Binary, when using a binary, we write the whole record data to the file at one time. The numbers in the binary record will not be readable this way. So if you were to intercept a binary file without reading it correctly or without knowing how it was written, to read it correctly, you got to figure out how it was written first. If that makes sense. And so if you're writing a binary file and every binary file is written, let's say 20 array characters, if you don't read it with that 20 array character sequencing, it's going to come in weird. It's not going to come in right, if that makes sense. And so I'll give you an example of binary file programs. Music databases that hold large amounts of data for music will use binary for the audio file name and point on it's pointed to on the database. Music, video is the same, and again, it's just for the index, not the actual file, not the actual music file or the video file, but just the indexing. Programs that create data files will differ on how they open and write. We'll get into that in just a second. And then types of different file access: sequential and random. Sequential is where you access each line of data one by one, much like a tape, and you're going to have to read in sequential from beginning to end. If you remember, like the old cassette tapes, you remember having to, if you listen to Back in Black by AC/DC, like I did in high school, and you wanted to find the middle song, you had to forward fast until you got to the middle of that cassette tape, right? There was no just hit a button and went right to the middle song. You had to sequentially go from beginning of the tape to the middle of the tape. So that's sequential. Random, or it's called direct access, is where you can jump to any location. Another example of this would be when we went from cassette tape to 8-track. 8-track actually had different tracks you could click on, like 8, 10 tracks, right? And then went from that to what was after 8-track? I don't know.
After 8-track?
Well, the actual hard. What do we listen to music on after 8-track tape?
Or records?
Well, after that, in your car, CD, yeah, and CDs you could do tracks as well, right? Track 1, 2, 3, whatever. That is random access. So you could literally click on a number and go right to the song, right to the song, or it's actually direct access. And so it would have a pointer on the file to directly access that unique file. So the first example we're going to look at is this example, just this real crude example called C write to and read from file. So click on that in the examples, and it should look like this here. I'll. 'll. 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 ' Okay, so first thing you'll note in this file, it's got 3 include statements, an F stream and an IO stream needed for our input output. Inside the main on line 13, I'm declaring an OF stream to create the file rbc.txt, and I'm calling it my out file, OF stream my out file. If we wanted to, which we'll do in the next example here, we'll play with it a little bit. If we wanted to append this every time it ran, we would just change on line 15 the OF stream my out file rbc.text end quote comma std colon ios underscore base colon app would change it to an append instead of a it'll recreate it every time with the way it is right now. We'll just recreate it. You'll see what it'll do in a second. On line 18, it's going to write out to the my out file. The stream is going to write out right into this file, rbc.txt. Line 20, it's going to write out, and also this, line 22, and this. Line 38 closes that file. Line 41 begins and declares a read stream called IF stream, my in file. I open it on line 44 with the input flag there. Line 47, I just declare a string to hold each line of text. 51 or 50 through 53 does a while loop, and it loops through each line till it gets to the end of line. When it does, it's going to stop. Then close on 56. That my end file. So let's go ahead and run it. We created the file on your end though. On my end, I've already created mine earlier. Your rbc.txt may or may not show up after a second. It should, but it might not. How many did it not show up? The rbc.text when you ran it. No? Did yours not show up? It did? Okay, cool. So if it didn't show up, one of the easiest way to do it, just to confirm it was there, is to just create it. Now I'm just going to show you real quick. If we click on it, rbc.txt, notice it wrote the file, created it, and wrote that text to the file, writing this to file rbc.text, and also this and this. Now if we click on this ellipsis here to the right of rbc.text and delete it, so yes, I want to delete it. In Replit, you can come over here and create a file or a folder. If I click on this file and just type in rbc.txt, hit return, go back to my main.cpp, run the app again. I'll have to refresh the page. Now I'm going to run it. There you go. And now it's in there. So this should create it. But again, it's good programming practice. That's what I was looking for earlier. Good programming practice to create the file if you already know what's going to be called already initially. But you don't have to. The code should do it for you. So what I'm going to have you do is a couple comments in here. I'm going to have you do. I'm going to have you. I'm going to expand mine out here. You're going to create a first comment here is to create a new line in the file for your first name, and then create a new line in the file for your last name. And go ahead and do that. And if you want, you can put it on lines 29 and 36 if you want to. And it's the same syntax that was used before to write to the file. So go ahead and do that. So again, on 29 and 36, you're going to put in there, on 29, you're going to write to the file your first name, and 34, write to the file your last name. And then run it to test it to make sure it works. And not only in the output, but also by looking at the file itself. Do I know?
Can you scroll up to
And this is the example file from 11 example, Jack, the first one.
Yeah. Yeah. It's using G++.
Okay. And if you get done with that quickly, which you probably will, go ahead and change the OF stream on line 13. You can comment that out and uncomment out the line 15 line if you want to, just to see what happens when you change that flag to append and run it a few times. See what happens with that rvc.txt file and your output now. If you change it from the non-appending flag to where it's going to create it, override it each time, that file, rvc.txt, to the append flag, which is the iOS-based app flag on line 15. You will have to comment out though 13, or you can add it to 13 if you want to. If you want to type it in, it's up to you. And just rerun that again to see what happens when you do that. Okay, I've got mine up here where I've got the added in the or commented out line 13, uncommented out line 15, which adds in the flag for appending that file once it's been opened to create or created to write as an append file. And then I added the first name on line 29, Chuck, last name on line 37. And you can see on the right, I ran it a couple times and it's actually doing its append job here. And refresh my browser here. There we go. And you'll notice, depending on the browser, how many he's hitting it, I've noticed that doesn't show up sometimes on here. I have to just, you can add it if you want to. I'm not going to, but you could. It is showing up. It is creating it, by the way, in the file server. It's just not showing over here on Replit. Because if I keep hitting run, it's going to keep adding it to that file. There we go. And so that's the first example. Again, just showing how the F stream, IO stream works. Again, just a note, when you're creating a file to do whatever, to write, you're going to either, if you do no flag, it's going to override every time, which it was on line 13 originally. If you add in the app flag, it's going to append. And then just make sure, like on both the writing and reading, the OF stream was closed on line 40. The IF stream for reading was declared on line 43, but closed on line 58. So make sure that you do that. And that's one of the first things I do in my database programs is I make sure and create the opening and closing first before I do anything else. Even before I put any work into what I'm writing, reading, all that good stuff. Opening and closing, get that done first. That way you don't forget it, because that's one of the first things you'll forget. Okay, the second example you can click on, which is the fave color numbers. It should look like this one here. And it is the same declarations for F stream, IO stream string. This one here uses a class called myfaves. And in the class, it's a public class that basically has in it a string called fave color, an integer called fave number, and then a function called get data that I clear out the color first initially, and then just ask them to add favorite color to see it with a get line. Then enter the favorite number for fave number. And then in the main, you'll notice declaring that class and creating a copy of it here with my faves S. So now S is now all of the class for my faves. On line 39, creating an append creation with faves.txt. Now here's the first time we included the if statement, if not file, meaning if that file was not created or didn't exist or something went weird, whether I named something wrong or declared something wrong, I would give it an error that this file was something wrong in the creation of it. Else, it should kick out the file was created successfully. S.getData is going to get input from the user for their favorite color and favorite number. It's going to come back on line 56, and I've concocted a string called writeLine with color, s.faveColor, number, and then because it's an integer, using the C++ toString, we'll convert that integer to a string. And then on line 57, I'm using that writeLine string to write it to the file. Line 59, closing that file. Line 60, just saying file is successful. Line 64, declaring an F stream for inputting and reading data. Opening that faves.txt file with the in. And by the way, you don't have to do the in. It'll do it anyway. It's a default. The in is a flag default. I just put it in there. That's going to be the default if you don't put one in there. So if not file one, meaning it couldn't open it, couldn't find it, whatever, it's going to give an error. Otherwise, it's going to say it's successful. Another string here, a loop to read through each line to the end of the file, and then closing the file. So let's go ahead and run it. And I'm going to put in green for favorite color. And I'll put in number 7 for favorite number. And it says faves.txt file saved and closed successfully. Faves.txt file read successfully. Here is a list of faves. And I'm going to run it one more time. And it did create the faves.txt file. I saw show up in the replit. I'm going to put another one blue. I'm running it the second time, 20 for number. Now it shows at the bottom both the color green, number 7, and the color blue, number 20. And if I click on that faves.txt file, it shows it accordingly as well in that file that I've just written and read, both. So what you're going to do with this one is you're going to change it a little bit, not much, but you're going to add in it a variable for a favorite movie, and I would say a string variable. Number 2, make sure and put a scene.ignore after the line 24, so it'll ignore the enter or return key after you hit the number, whatever that number might be. Otherwise, it'll eat it on the next one for movie when you do a CN for movie. And then in the main, make sure and update in the main the line 56 writeLine to include the new favorite movie. So right now it's color, number. You'll just add a new to the end, favorite movie. Okay. And make sure when you're concoctating strings, you remember to put the plus in between the concatenation, and put commas in between each one, just so it'll be create like a comma delimited file. If we were to import this, by the way, into a Excel file, it would create 3 nice columns for us for an Excel file. Okay. So just 4 things you need to do. I'm gonna go check the water. Be right back. Oh, that's better. My screen went to night mode. All right. I might scroll down to the concatenation part. That might be the trickiest for some. Just yeah.
Do you know if you can still get a free 3-day version of Visual C++?
Oh yeah, definitely. Oh yeah, Microsoft's still good about that. Yeah. All right, I'm jumping ahead to my line 61, which where you had to add in the favorite movie to your string for right line. Again, just adding to it the plus, beginning quote, comma, space, end quote, plus, beginning quote, favorite movie, colon, space, end quote, plus, s dot fave movie, semicolon. Now, just a word warning when you're declaring your variables in your class. The reason I can use a fave movie and fave number and fave color is because in the class, these are all under public variables. If you declare yours as private, will not work, but it will work in this case here. So I declared on mine a fave movie called string fave movie, and then I just always practice if I don't declare variable with a value, especially a string, I null it out initially because years ago you couldn't do it. You had to initialize everything with something. So anyway, that's just you don't technically have to anymore, but it's not good. It's not bad practice to. Compiler, I think, likes it a little bit better. And then anyway, entering favorite color is already in there for the CN for favorite color. Favorite number is already in there. Adding in the CN.ignore to ignore the return key after the user enters in the number. If you don't put in the CN.ignore, it'll eat it here on this next CN get line on learn 35. It'll just skip it basically. It'll use basically your enter key or return key for fave movie, which will be nothing. And then on the 35, doing a C out for entering favorite movie. 34, I'm sorry. And then 35, I did a get line, CN fave movie to get that. And then I already showed you the add-in for the concatenated string for right line. And so I'll go ahead and run mine here. I'll put green in again. 7. But what about Bob? Says it was created. There's my first record, and then the text file should show accordingly. I'm going to run it again and add another record to that. This time I'll put blue, number 20, and somebody give me your favorite movie. What is it? The Matrix. All right. I didn't like the. I like the first one. I didn't like any of the ones after that. All right, there you go. So added to that as well on the faves.text as well. And again, the reason I put the commas in here is if we wanted to bring this text file into Excel, we could easily bring it in and it would bring the columns easily that way. Good. Now let's go to the take home. You're going to add to what we've done already. The objective is to create a birthday database, program name and age of the user, birth date, either one. Birth date would probably be better. You could do age though. Into a text database, contact.txt. Create a class named student that collects the name and birth date. Then from int main, call student class and append to the contact.txt. Output, an example would be Tom Jones, birth date mm-dd, 923. So that's going to have to be a string. And file saved. I put in mine. The second one, my birthday, my name and birth date, and the second, or mine was the first one. Tom Jones was the second one. Mine was 811. Tom Jones was 923. Challenge. This shouldn't be too hard. But a challenge would be allow input until the user enters the Q key. All right. And we've done that already in here. I think we did a -1 on 1 week, I believe. I'm not mistaken. So same concept. You're just using a Q care instead of a -1. While the statement is looping, it'll continue to loop for input until the Q is entered. Once a Q is entered, meaning they want to quit, then it's going to show the log of all the birth dates. Sound good? Questiones. All right. Also, back up to the final helps. If you need final helps between now and next Monday, which some of you probably will, send me what help you're needing via email. Send me what you got already too, if you have something you already started. That way I can help you. And again, reiterating what I mentioned last week, each week spend at least 2 to 3 hours on your final app, I would say, minimum, at least that. That way, and you might get done early, but that's fine. Well, when you get done to the place to where it's ready to test, for others to test, just send your friends and family. You can send me the link as well, and I can help test it if you like, to make sure everything's working for you. And then, that way the day of our presentation at the end of the semester, it'll all be ready. Okay. So if you do get done a little bit early, like say you get done a week early and you think you're going to get done, that just means more testing you get done and maybe more tweaks at the end there of your app. Make sense? Questions? Okay, well, we're done. If you have any questions, come up and see me. Next week, I will bring a pile of reference books up here. I'm going to probably bring 8 to 10 C++ references. Some of them have been around a while, but they're good reference books. And again, I'll put a sign-up sheet probably up here and have you guys just sign up which one you took. And then I'll use the honor system, just bring it back. You don't have to bring it back the last week of class. Just bring it back whenever you're done with it. I mean, if it's one of those deals to where you're like, I love this, I got to have it, more than likely I'll let you have it. Okay. Because most of these books I have like 2 of anyway. So it's not going to really kill me if you want it and you're going to actually use it. Okay. So I have no problem with that. Do I now? Back then, yeah. When I first got them, yeah. But a lot of these I got free. So, but some of them I did have to pay for. So anyway, either way, email me if you have questions on your final app. Work on it this week, next week, same deal. If you want to work on it from home, you can keep working on it. We are going together, though. I'm looking at the schedule here. On week 14, I'm going to go to everybody's computer one by one and make sure where you're at, basically. With your app, I'll have you kind of show me what you got done on week 14, which is the week before we present. And then that way I know everybody's ready to go. Or you got a plan to be ready to go anyway. Make sense? All right. All done. Thanks for coming. Appreciate it.